Predicting redox reactions. So if you're given a redox reaction, how can you predict whether or not it's going to be spontaneous? In this example, we are given the net ionic equation for this redox reaction between aluminum and lead. You notice that the lead is an ion and there's an aluminum ion over here. So again, it's a net ionic equation, so it's missing the spectator ions in this reaction. We can see after we determine the oxidation numbers that aluminum goes from 0 to +3. Therefore, it's oxidized. Lead goes from +2 down to 0, so therefore it's reduced. The entity which is oxidized is called the reducing agent. That which is reduced is called the oxidizing agent. So this is a spontaneous reaction. We know this because the oxidizing agent is lead and the reducing agent is aluminum. But how does that tell us that this is spontaneous? By looking at the standard reduction potentials table, we find the two half reactions involved in this equation. The red signifies the oxidizing agent and the blue is the reducing agent. So more specifically, we're looking on the reactant side. Aluminum solid is the reducing agent. Lead ion is the oxidizing agent. There's the lead ion and there's the aluminum solid. When the oxidizing agent is higher than the reducing agent on the standard reduction potentials table, this line with a negative slope, then we say that the reaction is spontaneous. Here's another example. We have copper reacting with bromine. After finding the oxidation numbers, we see that copper is oxidized, therefore it's the reducing agent. Bromine is reduced, so it's the oxidizing agent. When we look in the standard reduction potentials table this time, we see that there are three half reactions that involve copper. We must choose the correct half reaction. We're looking for copper solid turning into copper ion, a 2+ ion. Here it is in the middle. So the copper solid is our reducing agent and the bromine is the oxidizing agent. Liquid bromine and solid copper. The oxidizing agent is higher than the reducing agent. This is a spontaneous reaction. The next example is shown here. Find the oxidation numbers. Sodium is reduced from +1 down to 0, so it's the oxidizing agent. Chromium is oxidized from +2 to +3, so it is the reducing agent. On the standard reduction potentials, we have two different equations that contain chromium. Which one do we need? We need the one that goes from 2+ to 3+. That's here. Sodium ion is the oxidizing agent and is below the reducing agent, so this is not going to be a spontaneous reaction. This is the last question. If a gold ring falls into a beaker of concentrated nitric acid, will the gold ring be destroyed? So the first thing we try to do is to come up with this equation. We put solid gold plus nitric acid, and it should form gold 3+ ion. What else does it form? We don't really know. What we do know is that the gold will be oxidized, and it will be the reducing agent. The nitric acid will be reduced, so it'll be the oxidizing agent. This is where you go to the standard reductions potential table, and you try to find the half reactions that fit. The half reaction for nitric acid is this one here. HNO2 plus 4H plus 4 electrons yields N2O, nitrous oxide, and 3H2O. So what you end up with are two half reactions, and see that the balanced chemical equation would be this, and we would cross out the 12 electrons here. And this would be our balanced chemical equation. Regardless, we can see that the HNO2 is reduced, so it's the oxidizing agent. And the gold is oxidized, so it's the reducing agent. Is the oxidizing agent higher than the reducing agent? No. So this is not a spontaneous reaction. That's our lesson on predicting redox reactions. I hope this helped. Thank you for listening.